I want to talk about Apple Intelligence today, and we are not getting it yet, right? At least on iOS and not in the EU. So my thought was, let's build it ourselves, right? Why not? And I want to preface this by saying I won't share too much code in this talk. I have a GitHub repo where everything is shared, so you can take a look at that afterwards, and I'll share the link. But I really wanted to take you more on the process of how I came to the solution to this problem. So just as a preface for this. And today I want to talk about three things, basically. The first is, why should we actually do this, right? Because, well, that's a good question to ask, right? Then what are we actually going to build? And then how are we actually building that? And let's start with the why. I'm not sure if you are aware, but every year Apple has an annual conference called WWDC where they introduce new things. And in this year's edition, it was all about Apple Intelligence, right? It's built in everywhere. It's built in across the system. Everything is built from the ground up. For the new iPhones, built from the ground up. Everything's great. Apple Intelligence is everywhere. Well, the only problem is it's not really there yet, right? So we can't use it, which made me sad, of course, right? And it's not completely correct that we can't use it. It's just here we can't use it, right? There are other parts of the world where it's already available, even for iOS. And I figured out, I finally understand the long-term plan behind Brexit, right? So that's what it's all about. And finally, we know. So good job there. And it's also available in other parts of the world. And first I was jealous, but then there's been some recent developments where I can say I'm less jealous now of other parts of the world. So that's fine, right? But we are in the EU, right? And with that comes certain things. One example is that we have AI regulation. So we have the AI Act. We have something called the DMA, the Digital Markets Act. And all these things prevent us from having Apple Intelligence. It helps us with privacy and other things. So I think, well, it's not all bad, right? So we have advantages due to it. But still, we're not getting that. So after a long time of crying and being sad, I actually started thinking. And I realized something. And I think I was the first person to realize this. Even inside this room, even I think Apple probably didn't realize that. So let's put on our tinfoil hats and let's go on a conspiracy theory here, right? So if you look very, very closely at Apple Intelligence, you will realize that if you switch up some letters here and there, you will actually get AI. No applause, that's fine, okay. All right, I realized that, and then I thought, well, that's good, right? Because Apple Intelligence, that sounds intimidating, but AI, well, we know about that, right? So we've heard of that in different tools. There's tools like ChatGPT, there's tools like Claude, which are more general purpose AI systems that help us in our daily lives, or at least most of the time. And then there's tools like GitHub Copilot, which is a coding assistant that analyzes our code and predicts what we will enter next and helps us with that. It's actually gotten a release for Xcode lately, so if you haven't checked that out, I highly recommend that. It's actually pretty good. And it goes even further. There are other tools like Cursor AI, which is not that known in the iOS community, but if you're going to web development or backend, this is a crazy capable tool where you can just describe a feature and it will code the whole thing for you. It's hit and miss, of course, so it doesn't always work perfectly, but it's impressive to see, really. But all of these tools have something in common, and that is where in the process of creating a product are they actually working? And all of them are working in the development process. So it's tools that we, as developers, use, and they help us in our daily lives. But then I wondered, like, what are we as developers actually doing, right? And if your answer is, well, we're using ChatGPT to write code, right? We let it write code for us so that we can save time for important things like discussing architectures and things like that. But actually, our real purpose are these people. And you might think, oh, what is that? That is our users, right? In the end, our goal is to ship apps that benefit these people. So the overall question I asked myself, really, is how can we use AI to build valuable features for these users? And I really will emphasize on that because, yes, we have AI integrated into the development process, but having that benefit the end users is really a different story. And I think it's important, not only for developers, but also for product marketing and everything, because these are the people who, in the end, are actually paying for the product. So there's a sense that we should probably make their life easier. So that's the why. That's what I wanted to at least mention before getting into the what we are building. But what is it, right? And the first thing to say is we're not building the entire thing, right? And there's different reasons for that. The first one being time. It's just, well, it would take a lot of time to rebuild the entire Apple Intelligence suite because it's just so much. And by saying so much, you can already see like there's a very broad scope of things that Apple Intelligence incorporates or will incorporate someday in the future. And this spans across the entire system. So Apple has promised to do integrations with messages, with mail, with photos, with voicemails, right? And all of these things have something in common. And that's the third problem that we have. And that is data. Because if you think about that, all the data that lies inside these tools, like messages, photos, are very personal. So it's private data from the users that we don't get access to, but Apple does. So that's the problems that we are facing, so we can't build the entire thing. So instead, I wanted to focus on 3 different things. The first one is for the features that we're building, I wanted to get the UX right. And that means the entire thing of like the animations, the experience that people have while using these features, and everything else. And I won't cover that during the talk, but like I said, you can have a look at the code. It has some nice animations because I love animations and some other nice tricks. But like I said, feel free to look at the code if you want to learn more about that. But the next challenge I wanted to give myself when solving this challenge was to use open source technology. And open source is great, right? It allows us to leverage what other people have done inside the community to use in our own projects and get the most out of it. So if you have the chance to either contribute to open source or support people who do, then always feel free to do that because it's really a valuable pillar of the entire community. And the last challenge I wanted to give myself was I wanted to run everything on device. Right? Apple Intelligence has this promise. Yes, you can like offload certain tasks to the cloud when it's more powerful capabilities needed. But the basic thing really runs on device. So that's the goal I had. But then I encountered one very large problem with that. And this large problem is that all these giant AI models, well, they are very large, right? So these are gigantic models. And just to compare that a little bit, we have GPT-4, which has 175 billion parameters. And that means 175 billion floating point numbers that you need in order to execute this model. And then we have other tools like Claude, where we actually don't really know because it's not shared publicly. but it's at least in the same ballpark, probably even larger. And then a while ago, Meta, a company who we all know and love, released their Llama 3.1 model that has 405 billion parameters. Like these are numbers that we just can't imagine, right? These are very, very large numbers. So the only way to run these models is in the cloud. These wouldn't fit on device. So we need to use the cloud to run them, which, unfortunately, is not really a solution for us because we want to run on device, right? But if we look at these models, there's one difference between them, actually. And the first two, these are proprietary models, which means the companies behind them, which are OpenAI and Anthropic, they're not sharing these models with the public. They're hidden behind an API that we can call and happily pay for, but the models are not really disclosed to us. The Llama model, on the other hand, is actually open source. So Meta is sharing the entire model for the community to use, which I think is great, right? It's a great development that tools like these are shared in the open source space. So that's a problem, right? We want to run on device, but these models are just too large. Yes, we have checked the open source checkmark. That's good. But we can't run on device. But there's been an interesting development in the AI space recently, and that is that smaller models are actually becoming more and more powerful. And one example for that is that the model that Meta released, the Llama 3.1 model, has a successor, which is called Llama 3.2, that only has 3 billion parameters. There's even smaller editions of that going down to 1 billion and fewer parameters. But at least it shows that this is really small, right? Well, relatively, right? So it's hard to get an understanding because these numbers are just so large. So let's look at a size comparison between the 405 billion parameter model compared to the 3 billion one. And the size on disk, if you would download the 405 billion parameter model, is 850 gigabyte. Which, I mean, some of you have probably shipped apps, right? And if you told your users, hey, just download our app, right? It's just 158 gigabytes. No chance. And that's not the only problem, because it might fit on a 1 terabyte iPhone, maybe. But in order to run the model, you would need to fit it in the RAM. And I don't know about you, but the phone that I have does currently not support under 850 gigabytes of RAM. So maybe in the future, who knows? But it's just not possible, right? And then the smaller model, on the other hand, this is actually just 1.81 gigabyte, which is still very large, but with the recent phones that we have, that actually fits on them, right? Not only in storage, but also in the RAM. So we can actually use that. But to really emphasize the difference in size here, I mean, everybody loves charts, right? So let's compare these side by side. And the 405 billion parameter model is this bar here. And for comparison of the size, this is the 3 billion parameter model. And we need to look really, really close to see, yes, it is there, but it's just ridiculously small in comparison, right? So this can actually run on the phone, which is great for us. So we solved the open source problem. We found models that actually are open source that we can use. And now we also fixed the on-device situation. So let's take a look at the UX. So this is actually the first feature that we're going to build. It is writing tools. And this is actually a screenshot of the app. You see we can enter a text, and if you read it closely, it contains some grammatical mistakes. So what we can do is we can tap on the top right here, and a writing tools option shows up. and we can tap on one option, for example, proofread, and we see this nice animation, and then the model will correct the text that it's given. We also have other options, right? We can open up the menu again and ask the AI to rewrite what we have, and it will happily do that. And we can even see the UI responding with the text being created step by step. So if we, for example, make it sound more professional, we can see it popping up and generating the text in real time. And this is not sped up. This is running live on the device. This is the speed that the AI reacts. Now, the second feature that we're going to build is Image Playground, which is way different, right? The first one is creating text and using a text model. And now we want to create images. And this works very similarly, right? We have a model, we're loading the model, and once it's finished loading, it says, hey, enter a text. And we can tap at the bottom of the text field here, which will pop up, and then we can enter a text that we like the image to look like. For example, a dreamy place with clouds and sun converging into a calm atmosphere. We tap on the button, we see the beautiful animation again, and after a while, the model generated the image, and we will show it to the user. We can also ask it to generate the same image in a different style, for example, in the comic style, and the model will again think, and after a while we get the same image, but only in a different style. We can also do more abstract styles that look like this, and just for the sake of it, we can also try a Santa version, because this time of the year is coming up, right? So I think it's really cool to see this, and that all of this is running on device, right? So I think that pretty much gave us an idea of what we are going to build. So let's start thinking about the how. And I mentioned that I wanted to take you on the journey of like how to explore building something like that, because to be completely honest, I actually wasn't sure how to do that, because it sounds like a really complex problem. We have AI models that we need to run somewhere. We need to figure out how to generate new images and stuff like that. So it's quite complex, right? But the good news here is that we don't need to reinvent the wheel, right? There is great resources out there that we can use to build this ourselves. And for example, there are tools by Apple. Apple provides a tool called mlx-swift, which I think ships with Xcode. And you can use it to train models, to execute them then on your devices. And it's great for certain use cases and works really, really well. But actually, we're not going to use it because for our use case, we don't want to build models on ourselves. The second cool tool from Apple is called Vision, the Vision framework. And this is used to analyze images. And it's also a really capable framework. You can analyze faces. You can estimate body poses and extract facial features in images. So it's really powerful. Not really fitting our use case. But if you have an app that wants to do these things, then you should definitely check out the Vision framework. And then there's one more framework that Apple gives us, and that is CoreML. And probably some of you have heard of that before, right? It's Apple's framework to run models on device, which sounds perfect for our use case. It comes with even more features. You can also convert models and have like an entire pipeline and tool chain around that. But for us, it's perfectly fine to just use these models to run them on the device. So these are the tools that come directly from Apple. But these are not enough for us, so we need more, right? And luckily, there is more. For example, there's the Swift Transformers package. This one is building on the Transformers architecture, which I'm not sure if all of you know, but this is the architecture that is actually powering these large LLMs like GPT. And all of that is based on a paper that was called Attention is All You Need, and every large LLM builds upon this. It's been getting more and more complex, of course, but this is the baseline architecture. And the Swift Transformers package is just the Swift port of that. The second nice tool that we're going to use is Hugging Face. And if you've not heard of Hugging Face, you can imagine them as the GitHub of AI models. Whenever a research facility or a company, a large corporation, is releasing models to the open source world, they're actually using Hugging Face to make them available. And they have a great website where you can try out these models directly on the website, and you can also download them, which will come in very handy for us. And the last library we're going to be using is mlx-swift. And it's a very important one, so I want to say a bit more about them. Because what it basically is, it's an open source port of MLX, which probably won't help you much, right? But MLX is a machine learning framework, and it's mainly used to train and run models on devices, which, well, that fits perfectly for us, right? We don't want to train models. We're fine just using the ones that we get provided from anywhere, but we want to definitely run them on device. And the cool thing that mlx-swift actually does is it is optimized to run on the GPU and the neural engine. And we've heard already that the neural engine is something that's quite powerful. And just to get an idea, because you probably hear the neural engine on the A18 Pro, which is the latest chip in Apple's keynotes, they usually say, hey, this can do now crazy amounts of operations. But I want you to think for a second how crazy high the number of operations per second that the neural engine is capable of is. It can do 35 trillion operations per second. I mean, I'm probably capable of doing 0.2, so I think it's quite more capable. It's just crazy, right? And remembering that these models are very large and require a lot of compute, it's really convenient for us to have a very capable engine to run these models. So it's great that mlx-swift optimizes the models to run on that architecture. So that's great, right? We have everything we need. We have Hugging Face, where we can get the open source model. That's nice. And then we have mlx-swift to download the model and execute it on our devices. That's perfect, right? So it's simple, right? And the bad answer is no, it's not that simple. We need to do quite a few things to get this up and running. But the good thing is, do we have help? And the answer is yes. Because I already mentioned a few tools, but also it's really cool that there's a lot of blog posts out there. For example, this one, which is from the Swift language team about running on-device ML research with MLX and Swift. There is great introductory content if you want to do things with mlx-swift. So you can check out this repo, for example. And there are also really great examples. And this repository specifically, called mlx-swift examples, is really a goldmine. So a lot of the code that I needed for creating this project is actually taken from this repo because it has excellent examples on how to run models on the device. So I highly recommend checking that out if you're interested in that. And I already mentioned the models, and this is a screenshot of the Hugging Face website. So we can get the models from there. And I think the cool thing is that there's different communities on Hugging Face. And actually, Apple is quite active on there. So they are actually actively sharing models there that they have optimized to run on their architecture. So that's really convenient for us, right? Perfect. So let's start with the implementation of writing tools. I already mentioned that we will use a lot of the code that is given to us. And it sounds intimidating at first, right? But if we take a close look at these repositories that actually do most of the work for us, actually. So in the end, all the preparation and everything needed we can take from the repositories. And for us, all that is remaining are actually 3 steps. We need to load the model on the device. We need to create the prompts that we want to give the model. And then we just need to run it. And we were starting at a very intimidating challenge that we had. But with the usage of the tools that I showed you, we can actually break this down to these rather simple steps, which I think is quite impressive, right? We don't need to have much knowledge about everything. We can actually use what others have built and build upon that. So for running the model, we first can check out a Llama model. And here we have a Llama 3.2 3 billion 4-bit quantized model that is available. And the 4-bit quantized is an interesting thing because this is an optimization that you can do with these models where you minimize the memory footprint by reducing the size of the floating point numbers that the model consists of. So this is already very optimized to be able to run on the device. So that's great. So when we want to start loading the model, we can now create a function. And let's call it load, and it gets 3 parameters. The first one is the hub API parameter that is part of the mlx-swift repository. And this actually is capable of downloading models from the Hugging Face hub, which is just their product where they keep all the AI models that we can download. We need to give it a model configuration. And this is the AI model that we want to use. So in our case, the Llama model. And we need to specify a few more parameters. So it's a little bit simplified, but this is the core of it. And then we have a progress handler that will just communicate the process to the progress to the consumer here. And then we create a model directory, which is basically just preparing a folder on the device to download the entire model into. And it takes the hub, the configuration, and the progress handler as parameters, and we can just call it. This function is taken from the mlx-swift examples repo, and it does a lot of the heavy lifting for us. And then the only thing we need to do is actually create this model container that will be the actual model on device, handing it the hub, the model directory, and the configuration, and we're done. So a very intimidating process at first actually came down to basically these 2 API calls of something that we are provided, which I think is incredible. Okay, we've loaded the model. So next we need to create the prompts. And you can see a screenshot from the UI that I've built. And it contains different options like proofread, rewrite, friendly tone, more professional tone, and others. So I think an enum is quite a good fit for that. So we create an enum called writing tool option, and we add all the cases that we want to support, like proofread, rewrite, and everything. Then we create an extension for that. We create a function inside that called generate prompt that we will hand the text that the user has entered. Then we switch over self, and then we can go through the cases. So for example, for the proofread case, we can say, we'll return the prompt of proofread the following text, correct any spelling, grammar, or punctuation errors without changing the meaning. Make sure the text reads smoothly and is error-free. And then we're appending the text the user entered. We can do the same thing for rewrite and all the other cases. And I really want to emphasize this again because having good prompts is really important, because this will actually determine the output quality of the model that you have. So it's definitely worth investing some time into creating good prompts. And who would have thought, but AI is really good at creating prompts. So you can describe what you want to achieve and ask the AI to create a good prompt. Because apparently these AI models, they just know how they talk to each other, right? Okay, so we created the prompts, we optimized them, and we're ready to go. So finally, we need to run the model. And again, this is a little bit simplified. You can take a look at the entire code in the repository. But it really boils down to a few function calls. So let's first create a function to run the model with the given text and the writing tool option. We load the model. We have seen the function call that we created for that. So we can load the model first. And then we create an array of messages, because these text models are usually optimized for chat use cases. And we can fake a chat use case with just a single message. We could also do follow-up questions and just appending to that array. But for now, a single entry into that array is perfect for us. We hand in an entry for the user role and give the content of the prompt that we have just created. Then we need to create a tokenized version of the messages that we hand in. And what this basically means is, we've heard of that before, it's a mathematical representation that the model can work with. And we get this tokenizer for free. We get this by downloading the model, and it's going to be accessible for us. And then it becomes really easy. We simply call the generate function on the model container. We hand in the model, we hand in the tokenizer, and we get each token that is generated in a completion handler. And then we can say, okay, we ask the tokenizer to decode that token, so that mathematical representation, into real text, and then simple append it to the result. So this is actually all the code needed. And if we take a look at the end result, we have text, in this case a list, and we can ask it to make this sound a little bit more friendly. We see the animation, and we see the model generating that in real time. So I think we've achieved the writing tools part. So next, let's jump to the image playground. And unfortunately, this is a little bit more complex, because for the writing tools, we could use a text model. For the image playground, we need to do image generation, which is just a different use case. And over the past years, there's been a certain family of models that has been really good at this task, which is called diffusion models. And they're actually quite fascinating how they work. They basically start out with random noise in an image, and then they take the prompt that the user asks for, and then it tries to combine these different pixels into shapes, and over an iterative process, finally gives out more complex shapes and then the final image. So it's a very interesting concept. If you're interested in that, definitely read up on that. But we have a very similar situation here, because there have been very popular models. There's been DALL-E 3 by OpenAI. There's been Midjourney, and there's been Stable Diffusion, just to name a few. But we're encountering a very similar situation that we've encountered before, because DALL-E 3 and Midjourney are again proprietary models. So these are not shared with us, but are actually hidden behind an API. Stable Diffusion, on the other hand, which is a model from a company called Stability AI, this is open source again. So that's great for us, right? Perfect for our use case. We can use that. So the first thing we're doing is we're going to Hugging Face, and we're searching for a Stable Diffusion model. And we're lucky, because we're getting exactly that. If you look closely, this is even a model that comes directly from Apple. So it's a CoreML model, perfect for our use case, that Apple provides for us to run Stable Diffusion on Apple's platforms. That's great. We can perfectly use that, right? And we've done the writing tools, so probably everything's going to be similar, right? Yeah, kind of. But we need to do just a few more things to implement. We need to do schedulers, step counts, guidance scales, pipelines. We need to handle negative prompts, compute units, pipeline loaders, all this crazy amount of things, which, as I mentioned, are a bit more complex. But then again, there is an example for calling a Stable Diffusion model that you can find on GitHub, which takes care of all of these things. So actually, we don't need to do any of that, right? We need to do some setup to be able to run this in our app. But really, we can leverage most of the things that we're getting. And in the end, we can focus on 3 things. And that is load the model, create the prompts, and run the model. And this might look familiar, because in the end, this is the same process that we've used in the text generation example. So what I'm trying to say here is that I think it's quite impressive that although it's a very different use case that we have with image generation, it's really cool that through the code and the examples that we're provided, we can actually break this down to a rather simple process that looks very similar across the different use cases that we had. And in the end, this looks like this, right? I already showed you this. We can enter a text. The model is loaded. So we enter the text, and then we tap on the button, and the model will load for a second, and then it will generate an image. So that's great, right? We build up the features, so we've covered the how. But before we finish, I want to do one more thing, and that is to answer the question of how well does it actually work. Because I mentioned that for the image generator, for the writing tools, this was running in real time. I didn't mention the same thing for image generation, so maybe I cheated a little bit. And I want to talk about 2 things for analyzing how well everything works, and that is the developer experience and the performance. The developer experience is kind of night and day. So on the one hand, if you encounter errors, it can be really challenging, because this is not something like the usual errors or bugs that we encounter when we develop applications, but there will be just very random feeling error messages that we don't really know how to handle. So that's actually been quite frustrating at times when I created the project, because I really didn't know where to start. But then on the flip side, while the community that is building these models and is working on these technologies is not that large, they're actually quite active. And I've already showed you all the resources that there's out there that you can use in your applications. But also, these people are quite approachable. So for example, I had a problem that I couldn't solve. I created an issue in the GitHub repo for mlx-swift, and within 24 hours, a member of the core team there responded and solved my problem. So great. So I think, yes, it's challenging at times, but overall, I would say the developer experience is actually quite okay, and you can get quite far with the tooling that's out there. So then let's talk about the performance. And let's first look at the model sizes. I already shared with you that the Llama 3.2 model is 1.81 gigabyte. The Stable Diffusion model that we used in the project is a little bit over 3 gigabyte. This isn't a problem per se, because we don't need to ship this with the binary that we're actually uploading to the App Store. But at some point in the process, we actually need to download this model. And if the user, for example, is on a very fast Wi-Fi connection, then it might be fine to download 1.8 gigabyte. It might take a while, but still it could be fine. But if you're on cellular data, that might actually become a problem. So it's not necessarily a deal breaker, but it's just something to really consider when we are shipping an app that contains one of these. The next metric I want to take a look at is the initialization time. And for the Llama model, it actually takes around a second for it to initialize. And I think that's perfectly usable, right? It takes 1 second, we open up the app, we can initialize the model, and it's there for us to be used. The Stable Diffusion model takes around 3 minutes, which is not a problem in and of itself. But if your user just wants to jump into the app and quickly create an image, and they need to wait 3 minutes to actually get that and wait for the model to initialize, that might be a problem, right? So it's not a deal breaker again, but it's still something to consider when building these features. And finally, I want to talk about the generation time it takes for these models. The Llama model is creating around 30 tokens per second. And you can think of a token more or less like a word. And I think that's quite usable. You saw it in action in the demos that I shared. And this was actually running on a iPhone 16 Pro, so it's the latest generation, which probably is really capable, right? And it can run at a fast speed. But even if you consider it being half the speed or even lower, it's still an okay way to create tokens for the users, and they can get an answer quite quickly. The duration for the Stable Diffusion model to generate an image is 25 seconds, which is way slower. So I actually sped that up in the demos just to fool you. So 25 seconds is still okay, right? But definitely something we need to communicate to the users when they use our app, so they don't just wait and think, well, that thing's broken, right? So again, it's something to consider. So when we think of these things as problems, we have a few ways to tackle that. And the first one would be to use different models. And we don't need to rely on these two that I showed you, but there's quite different models out there. The second one is that we can do optimizations. We saw that for the Llama model, which was this 4-bit quantized model, which told us it's optimized because just the memory footprint is smaller, and with that the model consumes less space on the disk and is also faster to execute. So in the end, I think it comes down to having a balance between having large models that are really powerful and capable, but also take a long time to download, initialize, and generate things, or to use smaller models that might not be that capable, but are actually faster to download and use. So in the end, it's a balance, and we need to think about and experiment with the model sizes and the additions that we need. All right, so I think, to recap, the UX part, I think we pretty much solved this. I think the outcome looks decent, so I think we can check that. We could rely on open source technologies to build that product in the end, and that's been working great. And finally, we were able to run everything that we created on device, and with that, we really respected the privacy that Apple incorporates. So I think Apple would be proud of us for creating a maybe better version of Apple Intelligence. We might see. Thank you for listening.